Good evening, all. So, welcome back to NeuroTechX Showcase. This is Season 2, Episode 2. And on this occasion, our fearless leader, Dr. Cristiano Michele, is sadly not with us. He is on a business trip in Europe. So, this was an excellent opportunity for me. I'm John Griffiths. Nice to see you all. For me to bring forth from the shadows our other co-organizer, Brian Jenkins, who, I'm not saying you kind of lurk in the shadows, Brian, but you have been, pulling the strings and doing the co-organizing at the back for all the way through for since we started this initiative. So it's great to have you up with us for a kind of front and center discussion today. So I actually, in our kind of little opening chat, and what we have lined up for you guys, we have an excellent talk and an interesting discussion, hopefully, with Ty McKinney and Shannon Snaden from Bit Cortex, which is a healthcare startup based out of Calgary. So we're going to be having Ty and Shannon up in 10 to 15 minutes, and we'll have, just to give you guys an idea of like structure here, we're going to have a little bit of back and forth, and Ty is going to give us some discussion of their platform and also a demo of their app, which is really interesting, and I think it's it's a new piece of tech. Like they've really been putting the work in to get this thing together over the last few months, so it's going to be kind of piloting here. So we've got that coming up, but first I wanted to kind of throw it over to you, Brian, because for those of you who don't know, Brian is high up in the world of neurotech, the echelons of NeuroTechX, in the sense that Brian is doing a lot of fantastic work, basically pulling together our kind of international family of enthusiasts, scientists, engineers, entrepreneurs, and other interesting people who are involved in our organization. So Brian, why don't you tell us a little bit about your role in NeuroTechX, and then anything else interesting you want to tell us?
Sure. Thank you, John. And I'll say to everyone here today, thanks so much for your interest and your attendance this evening. It's a particular pleasure for me to be on this side of the dynamic. Chris has certainly big shoes to fill, and I'll do my best to operate as Chris today. So I've been with NeuroTechX for over 5 years now. My role officially is Connectome Manager, which means that I get the pleasure of working with many different communities within our kind of Connectome framework around the world. So we have around 30 chapters active globally, running different neurotech related experiences for their fellow community members, for their fellow neurotech enthusiasts. And so myself, along with a team of 4 currently, and we're expanding every few months or so, I get to coordinate all of those fantastic fun experiences like the one that you're participating in today. So beyond that, I will talk a bit about NeuroTechX, and I think I will share my screen here just to show some of the stuff we're talking about and get you a frame of reference here. So you should see the NeuroTechX website. And so NeuroTechX, as many of you may know and some may not, is the largest international community for neurotechnology enthusiasts. Our community reaches over 16,000 people worldwide, with over 6,500 members online in Slack now, and this is rising every single day. It's a volunteer-led nonprofit organization, and our mission is to facilitate the advancement of neurotechnology. Now, this is broad by design. We are tackling this at 360 degrees. And so within our community, we've established over 13 initiatives now, all volunteer-led. They all are built around our 3 pillars, which are community, education, and professional development or innovation. And so a couple initiatives that I'd like to highlight today that you may not necessarily be aware of if you're only checking the NeuroTechX website would be our Content Lab. This is a relatively new initiative where we have a team of writers, designers, editors, and project managers creating, collating, and publishing content across many different channels within NeuroTechX. This could be content that has been produced within the NeuroTechX community, or content that is just of interest to neurotechnology enthusiasts within and outside of the NeuroTechX community. And I do believe that there's an open call right now for individuals to join the team as writers, as editors, possibly even as some project managers and other roles. So if you're interested in producing content, managing content, or just getting involved with the NeuroTechX community, please do check out our socials. Make sure to join our newsletter so you can find out about those open roles with Content Lab. I think I'll also maybe take a moment to briefly highlight 2 other initiatives that we're seeing a lot of success through recently. So one of them I'll touch on is Nortec X Services, which is actually kind of more of an independent entity itself that works closely with the NeuroTechX community. And this is kind of your one-stop shop for neurotechnology needs. So this could be some consulting work on getting your business plan into shape, or your go-to-market strategy, or maybe you're looking to get a sense of how best to acquire skills within the neurotechnology field to ready yourself as a professional in neurotechnology, or maybe simply you're looking for a job and you want to get an internship or your kind of career role. You can always go to NeuroTechX Services for that and more. So, beyond that, I think I'd also like to briefly promo the education initiative, NeuroTech EDU. And we have a bunch of different courses online that you can train through. You can get certificates in neurotechnology. These are courses that are built by the community for the community, and you get to learn a lot and grow together. So it's a really exciting time. And we do have a couple really interesting announcements coming through from our EDU initiative in the coming months. I can't say more, but definitely join and follow and stay tuned for some really cool updates soon. So with that, I think maybe I will talk briefly about my research. I know, John, you wanted for me to touch briefly on some of the stuff that I'm doing outside of neurotech.
Yeah. Well, but I actually thought I just comment briefly on the Content Lab stuff. I mean, something that I've been impressed by. I'm actually curious what's involved. I know that you aren't necessarily kind of front and center of it, but the like production value of the content that's coming from the Content Lab is really nice. Like it's all glossy and well organized and looks like it's coming from a high quality production company, and it's cool to see that that's possible with, I guess, probably not a huge amount of expenditure on the investment side, just kind of motivated people who know how to use modern technology.
Yes, and I think that logic, or that sense extends across the whole NeuroTechX community. Everyone has many different things that they're working on. I think we're all very like-minded in that regard, and so yes, with the Content Lab, their exec team is fantastic. You've got some wonderful professionals like Shame and Sophie and Adam, who are beyond Content Lab, working in many other NTX initiatives, but really have an eye for how to speak or talk neurotech and really get that information out there in an engaging way. So huge hats off to the exec team, but also I think they have a team of 20 plus writers and editors that are all working together. So it's quite the talent pool within the NTX community, and that's being, I guess, showcased through the Content Lab. Yeah,
it's a real little kind of blogging mini production company entity going on there with the Content Lab. Yes. Which is awesome to see. I mean, it's particularly awesome to see that in on an interesting topic, or a topic that I find interesting. So yeah, Brian, let's kind of move it over. So I thought, given that we have you up here, and given the topic of the conversation that we'll be having with our guest speakers, it'd be also interesting to hear a little bit more from you about your own work, particularly because it intersects with some of the topics we'll be talking about later.
Yes, I'm definitely happy to chat. Sorry, just briefly, John, how do I stop screen sharing here? Is it click to close message?
I think I can stop it.
Okay. Thank you. There
we go.
That's better. I can see you more now. I'm sure. Yeah. So I guess I'm interested in this talk from Bit Cortex for many reasons. Number one, I've been connected with Ty for a little while now, Shannon and less so, but I'm happy to be connected today. And I've heard about Bit Cortex, and I've been kind of following some of what they're working on. Nothing to this extent, so I think it's going to be really exciting to learn from them about their journey. But also, it kind of touches on some of the research that I'm doing outside of my NeuroTechX work on the day-to-day. I am a PhD candidate in my final year. Oh my God. And so my research largely is focused on examining the neurobiological mechanisms that link cannabis use with schizophrenia. So we've all heard that cannabis use, particularly early age use with high potency cannabis, can lead to increased risk for developing schizophrenia later in life. And so we're really looking at why we see this strong association, really trying to tease apart some of the biological mechanisms underpinning that. And so, I am interested in that area of work, not to look at necessarily the negative consequences of cannabis use, which is one certain aspect of focus for some research groups, but I'm more so interested in understanding, okay, patients with schizophrenia are going to use cannabis. That's shown time and time again. It's incredibly high rates of use, as high as 80% of patients who use cannabis in their lifetime. How is it that we can utilize our understanding of the biology and our understanding of human use patterns to help minimize the harm that these patients may be taking on if they are using cannabis, if they're choosing to use cannabis? And so kind of bringing it back to neurotech and to Bit Cortex, and I do believe that technology will have a fundamental place in this dynamic. I think it'll be really helpful if we can create platforms that allow for patients or care providers or support networks to monitor and to understand the impact that cannabis use has on certain biosignals. So my work looks at how brain signal changes after being exposed to cannabinoids, after the brain changes due to exposure to cannabis, and how that relates to schizophrenia, how patients with schizophrenia may, how the brain signals from patients with schizophrenia may change after exposure. And so I envision that once we have more information, we can really start to harness that knowledge to create technologies that will allow for us to kind of mitigate that harm. Maybe there's a predictive brain signature or a set of signatures that would allow for us to understand that risk for this patient to use cannabis, or the threshold when maybe that use of cannabis is becoming too harmful, or where there's a greater risk for some symptom becoming present, etc. So with the talk here today, and not to expose too much of what 8-Bit is going to talk about, I know that they're really leveraging their expertise in brain science and in understanding brain signatures and activity patterns to help empower users with their own mental wellness and mental health. And so I certainly will learn a lot today from the journey that Ty and Shannon take us on, and I hopefully can apply that in my own research when I'm finished with my degree and looking at what's next.
Right, great, thanks, Brian. And this is definitely like an emergent theme that has come up in the discussions we've had so far. Honestly, all the discussions I have in this general area within this group and in other groups as well, this kind of intersection of obviously neurotech and other personal health or just personal data tracking, right? Kind of digital health infrastructure. Really kind of finding those opportunities to knit together information that otherwise exists, but whatever kind of isn't monitored or just kind of sits on some unconnected piece of information storage device, high digital or non-digital, or just dissipates into the ether, right? We're kind of moving past that into bringing in the information that we have in constructive ways, right? And then the constructive way is where the kind of USP of the interesting companies like 8-Bit Cortex really come in, right? So it's not just a case of aggregating, it's a case of aggregating with a methodology, with a kind of buy-in on the user side, and obviously a UX, like serious UX considerations. All these things come together, and that's been a consistent theme in a lot of the discussions we've had so far. So I think this is definitely the time to bring up our two guests. What I want to say first before we do that is, guys, as always, we want to hear from you, and we want this to be a discussion that has a number of contributions. So I'm going to point with my finger. There we go. The ask a question button there. Use it. Drop your questions in there. Let us know your thoughts. We're going to try and basically have some discussions along the way with Ty, and make this somewhat interactive. So if you pop your questions in early, then we'll try and get them answered as soon as possible. Wonderful. So without further ado, let's bring up our two guests. I'm going to... Here we go. Hello, Shannon. Hello, Ty. How are you guys?
Good, thank you.
Wonderful, thank you.
Excellent. Guys, today we've got Shannon Snaden and Ty McKinney. These are co-founders. I'm going to put this question to you guys now. Are you the sole co-founders, or are there more co-founders of 8-Bit Cortex?
So we're the co-founders that were there from the very beginning, and then we've got other team members that have contributed greatly. And basically, we're trying not to get too crazy about equity kind of stuff until we know for sure that everything's viable. So, while let's say like co-founders, like part of like a core team that is more extended.
Excellent. So welcome, Shannon and Ty. And what I want to do is actually just hand it over to you guys to do your own introductions. And then Ty, you have some slides, and you're going to kind of talk us through. So let's hear a bit about both you guys. Let's start with Shannon, actually. So Shannon, like, what's your bio? What kind of brought you into the entrepreneurial position that you're in now? And tell us about yourself.
For sure. So I was doing my MBA at University of Calgary, and I was exploring all the things that you can see, and I started looking into the entrepreneurship community and found that there was some really great resources and support there, and I discovered my newest hobby, which was hackathons. And so I entered into a bunch of different MIT hackathons and Innovation Olympics ones, and finally I discovered my favorite niche of hackathons, which was medical and neuroscience ones, and that's where I met Ty, and we got along really well. And when I was laid off from my job in continuous improvement at WestJet, where I'd been working on reducing injuries, physical injuries, Ty said, well, let's look at fixing injuries that happen in the brain. And that's how we started off on this journey with 8-Bit Cortex.
Great. So that was MBA. Did you say, Shannon? So you're the business head. Can I call you the business head? I'm just going to assume that you're the business head here.
Yeah, I bring the business side, and Ty brings the science side.
Okay, fantastic. So Ty, let's have the same from you. What's your brief bio?
Yeah, so Shannon and I met at that one hackathon competition. The project ended up not really going anywhere for that particular one, but again, the key thing is that Shannon and I realized that we could work well together. And at the time, I was trying to wrap up my own PhD down at the University of Utah in cognitive neuroscience. And it had this idea for an app for quite a while that could be used for tracking mental health, specifically doing cognitive assessment. And then when COVID happened, most of my responsibilities kind of disappeared overnight because I was no longer testing older adults for obvious reasons. So with the new amount of time that I had, Shannon and I decided to really push through and try to really develop this idea. And, how can we take this data collection platform that has some potential and gamify it so that people actually want to use it? Because from my personal experience working with patients and stuff like that, yeah, you can collect data, but they're going to be really frustrated by the end of it, and they're probably not going to like you. And if you're trying to get data out of people of their own volition, that's a no-go. So you need to have that engagement strategy kind of up front. So that's where the story of 8-Bit Cortex really kind of started to take off. And then we've had several pivots since then. With that, I could... Oh, sorry.
Yeah. Go. Let's bring up your slides, and you can jump in. I'm gonna probe you a little bit more while you're doing that. Just so you were working with, well, you said just now. So you were, I guess, doing EEG with older adults or something, cognitive neuroscience. And I know you did some stuff with rats before that, also EEGs. So like, what's the neuro knowledge of Ty McKinney?
So my undergraduate research was doing hippocampal neurophysiology, and it was looking at the relationship between protein synthesis inhibition and memory formation within hippocampus. And more or less, that's what got me to fall in love with EEG, because I just appreciated the elegance of this particular time series approach. The data that you could get from EEG was so fast, and you could look at the different features of the waveform, and it could start to reflect actual components of cognition. So when I decided I wanted to pursue grad school, I wanted to find a way that I could use that technology, but in more of an applied setting. So then I looked out trying to find professors that had experience doing cognitive assessment and EEG, and that's surprisingly few people, and that's how I ended up in Utah. And long story short, that's how I eventually ended up on the project, was looking at medial-frontal data with older adults and trying to use that as a potential biomarker for cognitive control and mental exertion.
Awesome. Yeah, so and EEG is a regular feature in our discussions, and in particularly mobile neurotechnology and kind of consumer neurotechnology. So I guess that's one of the reasons why you're in this space, and we're kind of somewhat familiar with your name and your face, Ty, in addition to the work with Bit Cortex. And maybe you'll have more to say about that later on, but why don't you jump in on this presentation?
Yep. Don't worry, there'll be a little bit more EEG to come about halfway through the presentation. So.
All right.
So thanks everyone for joining us this evening. So just to kind of start diving right into kind of the agenda. So we're going to start by thinking about the neuroscience of burnout. And while this is usually being defined from more of like a social psychology perspective, I want to dive into a little bit more, how will we actually try to get a sense of what burnout is from a physiological perspective? And critically, from my perspective, how do you actually measure that in such a way that it's scalable and can be useful in daily life? And I guess I'll give a little bit of spoilers. My solution to that was looking at temporal patterns and using patterns in time series data as the form of measurement itself. So we'll talk a little bit more about that, since that's one of my key research areas of expertise. And that'll lead into a demonstration for our app that'll highlight some of those features. And then we'll kind of, from there, think about some of the implications and how we could start using this app in a few different ways. For example, what it could look like to personalize mental wellness, talked a little bit about our commercialization strategy, and then finally thinking about how we can start using some of that information to make the workplace more inclusive. So we'll use the specific example of ADHD and entrepreneurship before wrapping up with some of our future directions. So to those of you who might not be as engrossed in this literature as I am, burnout is usually defined as being somewhat occupationally constrained, meaning that it's usually in relation to your job, or if you have a caregiver role, it can be associated with that as well. In addition to sometimes athletes will also experience burnout. So it's usually related to some sort of discrete occupation, which differentiates it from other mental health conditions or phenomena, which tend to be much more global in nature. So you can kind of think about it as a generalizable versus a specificity distinction, although there is quite a bit of overlap, as evidenced by the fact that there's people that are experiencing burnout are at increased risk for mental health challenges, and vice versa. People that have pre-existing mental health conditions are predisposed for elevated rates of burnout. And I feel like after the last year and a half, we've all kind of become aware of how important or how critical burnout can be for our own personal well-being. But what a lot of people might not necessarily be aware of is how expensive burnout is for our society and economic level. So there's one study that I really like to cite, where they looked at people that had a diagnosis of depression, and they linked that to reduced productivity within the workplace. This is over across a number of different countries. And they found that in Canada specifically, the cost was $3,500 per employee per year for employees that just weren't able to be fully present at work, and as a result had decreased productivity. So once you think about the scale of this for the Canadian economy, this is a lot of money that we're just kind of throwing away by not taking care of people in the workplace and making sure that they've got all the support and resources that they need to be successful. So this is kind of where the impetus for Bit Cortex really came from, is once we realize that there's these injuries in the brain and they can be really costly within the workplace, how can we find ways to try to alleviate this?
Ty, jump in on first question here. So I think you had just now in the previous slide, you had occupationally defined.
Yeah.
Maybe this is what you're going to on the next slide. But yeah, I'm curious, like what the official definitions are, if there's a kind of pseudo or a fully medical definition, and like what's the kind of Bible definitions and kind of framing of this phenomenon?
Yeah, no, that's a really good question. So for the most part, burnout up until this point has been a research construct that we've studied in a number of different capacities to try to understand what its impact within the workplace is. But the ICD-20 is actually going to be adding burnout as a diagnosable condition in its up-and-coming iteration. And that's basically a response to the fact that there's a lot of people that are suffering from burnout, in many cases due to work-related stress, but you can't get any medical attention for that because it's not a psychiatric condition properly. So they're actually adding in a new medical code so that people can get access to resources and get insurance benefits as it relates to burnout more easily, rather than needing to potentially get diagnosed with a mental health condition that they might not necessarily have, but would get them access to the resources and treatments necessary to improve their situation. Right.
And the ICD is, it's the WHO classification, right? So,
yeah.
What does that stand for?
So it's a general for all medical disorders. I think it's International Classification of Disorders, and then the number just specifies the version. It's very, very analogous to the DSM-5, which we're probably
exactly.
I imagine this community is a lot more familiar with.
Is it kind of parallel to the DSM-5? Is it covering the same things, or is it focus on areas that DSM doesn't cover? Like, what's the relationship between the two?
So I believe the ICD-20 is a little bit more broad in that it covers other general medical conditions as well, whereas the DSM is specific to psychiatric conditions. Yeah. But if you were to look within like the mental health psychiatric range, they're fairly congruent. It's just a matter of like which insurance code do you want to use. The conditions line up quite similarly.
I see. Thanks. Please continue.
Yeah, no worries. No, that was a good question. I can't see the question, so please just feel free to interrupt if there are any more popping up.
Don't worry, I will.
Yeah. So now we kind of got a sense of like why burnout is so important and some of the consequences it can have for the workplace. The next thing is to think about, okay, what are the individual factors? So this research is mostly being conducted by Christina Maslach. She was one of the first researchers to really dive into this. And she identified 3 different factors of burnout. So there's the sense of emotional exhaustion, where you're just tired, which I got a feeling we can all kind of relate to after 2020 and 2021 so far. But it's not just that. There's also the sense of a lack of accomplishment, where you're doing things, but they don't really matter, and you're not proud of your accomplishments. And this could either be in the sense that your accomplishments aren't being recognized, or you're so burnt out that you're not actually accomplishing anything. So both of those can feed into this other factor of a lack of accomplishment. And then there's this final piece of emotional detachment. So you can think about this as you're just really stopping to care about the occupation. So if you're a healthcare worker, this could mean not really caring about the quality of care that your patients are getting. So these are all fairly scary things once you think about some of the implications of them. But where I started to get really interested in this is, okay, so this is how we define things from a very psychological perspective. How can we start getting towards some of the basic science that underlies these? So when I think about emotional exhaustion, what I think about is a dysregulated HPA axis, which I'll get into in a little bit what that is. But the fact that we have this stress response system that's out of whack and not responding properly. When we think about the lack of accomplishment, I think that's better capitulated as lower executive functioning. And then the final piece is a little harder to conceptualize from a neuroscience perspective, so I just kind of put low trust here. But this is my attempt to take that psychological operationalization of burnout and define it a little bit more biologically, which allows it to be a little more tractable, and as a result, we can start using technology to work with it a little bit better. So I find it really helpful to think about burnout from a bit of an evolutionary perspective, because while it doesn't necessarily answer everything, it often does help us get a sense of the why for certain things. So burnout is obviously a really bad situation we don't want to find ourselves in, but it didn't come from nowhere. There's some sort of evolutionary mechanism behind why we might experience burnout. So that's kind of my starting place for trying to think about how to understand things a little better. And when you think about it, back when we were on the African savanna, we would have to regularly escape from predators, or species also engaged in what's called endurance hunting, where we'd literally chase gazelle down until they died of exhaustion. And this would involve a lot of running. So we would need to change our metabolism in order to have these spurts of energy so that we could escape from the predators, in this case, the bears, where we stole their fish from, or chase down those gazelles. And these experiences were very emotional. So as a result, we've kind of got this legacy now where when we experience highly emotional situations, this same physiological response starts to crop up within us. And the fight or flight system from the sympathetic nervous system is relatively short-lived. So this is where the HPA axis comes in, where we get our primary stress hormone cortisol. So basically what our stress response allows us to do is to take the activity of running and extend it out for long periods of time, sometimes upwards of hours. And then because cortisol is hormonal, it has a bit of a delay, so it doesn't act quite as quickly. And critically, it's a negative feedback loop system, meaning that once your cortisol levels go up, there's natural auto shut-off mechanisms within our brain and our biology for it to come back down. So you can kind of think about this as the same basic phenomena, but operating at different time scales, where when you first detect a threat, first of all, it's going to be your sympathetic nervous system is going to have these hardwired connections to all your different organs to prime it for responding to danger. So this could be things like increasing your heart rate, increasing your respiration rate, shutting down non-essential functions like digestion and sexual functions. And then there's also going to be this hormonal response that's going to come a little bit later from the HPA axis. And these all together combine to help us more effectively deal with threats. But one thing that's very different from us right now versus us tens of thousands of years ago is that we no longer experience the same kinds of stressors. So I don't know about you, but I haven't encountered bears in a really long time. So normally, from an evolutionary perspective, we would have one of these stressful experiences. We'd be under these situations of threats, and our stress hormones would go up, but then they would come back down because we had escaped from the predator. We'd be able to catch our lunch, and then we'd have this opportunity to rest and recover before we need to go hunting again or before a new predator comes about. But what tends to happen within more of our current society is we get this chronic stress phenomena, also referred to as allostatic stress, where we just keep getting more stress added on top of us, and we don't get the opportunity to properly recover. So as a result, our baseline stress level continuously starts to float up and up. And this is what leads to the dysregulation of the HPA axis that has a whole bunch of different health consequences that come along with it. And this is kind of the first thing that we can start to think about that I'll talk about as relates to our app, is really the distinction between normal stress versus chronic stress is a change in level, and that the overall average level of stress is slowly increasing. So just kind of keep this in the back of your mind, because this is going to be important for a little bit later on. So this kind of comes to the crux of the issue. So you're saying, Ty, that's awesome. We now understand that burnout is really important. We understand some of the physiology that goes behind it. But how do you measure that? How do you identify somebody that is at risk for burnout? So kind of thinking about this first part as it relates to chronic stress, there's a few different ways that we can start to measure it that have different pragmatics associated with it. So one of the best ways that you could go about trying to measure stress is by using hormone tests. So you can actually do saliva tests as well as blood tests in order to measure for cortisol levels. And oftentimes this is done in conjunction with some sort of a stressor challenge. Ironically enough, public speaking is often used as one of those public stressor challenges because it very, very reliably stresses people out. And then finally, there's also this psychological component to stress as well. So we can also measure it through self-reports. So then moving on to the next component to burnout that gets a little bit more towards the attention side, we're starting to get a little bit more cognitive in nature. which is where my area of expertise starts to come in. At one point, I thought it'd be really cool to do pure stress or social tasks and measuring cortisol in people, but turns out that research is not as much fun as you would have guessed. And I liked brainwaves a lot better, as we learned from the beginning bits. So there's a couple brain networks that are really important for our executive functioning. There's the frontal parietal network, which is really important for short-term modulation of behavior. So you can think about this as the moment-to-moment calibration of our attention. So this might be, for example, if you're doing some coding and you're realizing that you're using the wrong syntax, it's your frontal parietal network that would help you catch up, like, oh, sorry, I just made a mistake there. Let me catch up these typos and fix up the syntax so that my code can run. The other network is the singular opercular network. So this one is more important for sustained engagement of executive functioning. So you can think about this like, I have a lot of things to get done today, so let me get into my Zen state and just kind of power through it. It's the singular opercular network that's activating your frontal parietal network so that it can be engaged for that longer period of time. And both these networks have somewhat overlapping roles and roots within motivation and motor planning. So I'm going to get into this a little bit more to explain a little bit more concretely about what executive functioning is. And as you can tell, I really like using memes as a way to communicate some of my science. So one of the things that our executive functions are really important for is impulse inhibition. So we've all probably been there. We have these awesome plans we want to execute, and then we end up having this weird impulse, and then things don't go quite as planned. If you've ever experienced that, you've experienced a lapse in your executive functioning. And if you've ever been able to adhere to those best laid plans, you can thank your frontal parietal network for that. So this is kind of one of the core functions that this brain network does, but it has a lot of higher order potential as well. So in addition to that, because it's got this this rooting in motor planning, it also allows us to plan out complicated actions, which, if you kind of extrapolate a little bit more, is like us making up our to-do list and our planning. So we can think about, okay, what's the best to-do list that we're going to come up with for today in order to meet our various goals and objectives. And critically, this can actually, some people might construe this as being a form of self-control, because it's basically our ability to self-regulate, to inhibit our prepotent dispositions in order to achieve our goals. There's a lot of research looking into how these two networks are interrelated with goal-seeking behaviors and planning. And one thing that's relatively important is that dopamine is one of the neurotransmitters that's used for communicating between these two networks that I kind of like to think about as the motivational throttle, where if you have if you get a shot of dopamine from one source or another, that can actually help turn on your executive function so that you can properly deal with what would be a surprising threat or a surprising scenario. And this is where we start to get to the how these networks can relate to burnout. Because if we're experiencing high degrees of chronic stress, those stress hormones like cortisol can actually interact with our frontal parietal network, and they can cause them to be not quite as effective. And one consequence of this within the workplace is that we can lose our attention to detail. We can lose our sense of inhibition. And I don't know about you, but I, in many cases, paid for my ability to pay attention to details. So not being able to execute that cognitive capacity to my fullest extent can be quite detrimental. And the inability to do that is what's going to lead towards that sense of inefficacy in our workplace. The fact that we're trying to do these different cognitive operations and it's not quite getting us where we need to go. So this is one of the other risk factors that's really integral as it relates to burnout. So then we kind of come to the next piece, which is how do we measure that? So now we kind of understand how these two brain networks fit together. How do we actually take that and make it usable in more day-to-day sense? So one way that I've got some training in is cognitive tests. Often used in research studies or in clinical neuropsychology, often with brain damage patients and older adults that are at risk for cognitive decline. Is we can actually do standardized tests that measure your executive functions. The problem is that these tests are incredibly boring and tedious. to the point where I'd have to say to the patients that I was working with, hey, just so you know, the next 2 hours are going to suck. I'm going to ask you to do things that are really boring, and you're probably not going to like me by the end of it, but we're going to get some really valuable data that's going to give us some insight into how you're doing. So please just bear with us. So that's one way that you can go about measuring attention and cognition. Another way that you can do it is similar with chronic stress, is you can just directly ask people using self-report methodology such as surveys. Which again, as you can appreciate, there's some bias that goes into that. It's not as objective as a cognitive test with normative responses, but it's a lot easier to administer, and it's still useful information despite its weaknesses. But the other way that we could potentially measure this, which was the focus of my PhD work when I met Shannon, was how can we use EEG as a way to understand the functionality of these networks in a more objective basis, as a way to complement a cognitive test that we might be doing. So since at NeuroTechX, we're all really excited about brain-computer interfaces and EEG technology, I want to focus a little bit more on how we could use that, because this is one of the possible things that Bit Cortex would like to incorporate in the future.
Ty, I got a question before maybe you move into this section, is on so like chronic stress, maybe burnout, but I think about like chronic stress area. I mean, this is like a somewhat well-studied phenomenon in general. I know the kind of animal models for this, it's like, it sounds a bit, well, it is somewhat unpleasant, but you put mice on a heated surface, right, so that they kind of can't, this is the one that I'm familiar with, it kind of keeps them on edge. It keeps them agitated. They can't keep their paws down for too long, so they have to kind of keep walking around. So there are animal models of chronic stress, but I'm curious, like, what are the main animal models, but also in the human sphere, right? What are like canonical chronically stressed situations? I mean, a few come to mind, right? Like, obviously, it's a profession related is the obvious one. People who have stressful jobs, people who work really long hours, family as well, people who are single parents, etc. But are there like, the canonical chronically stressed individual? What is that kind of phenotype, do you say? Like, if in studies of, say, like cognitive neuroscience studies, they tend to look to samples of people who are doctors or care workers or something. Do you know what I mean? Like, what are the kind of key examples here of those populations?
Yeah. So I like that you kind of started up by talking about the animal research, because I think like that's often a really good way to understand like the basic science of what's going on. And I know I actually had not heard about the paradigm that you had mentioned before, but the one that I'm most familiar with, it's basically you're chronically irritating the rats. So you're doing things like rotating the cages, like shaking the cages on occasion. Nothing that's like overly traumatic for them, but like over time is going to really start to irritate them and kind of put them on edge.
Same kind of thing.
Yeah. The worst I ever put my rats through was a fear conditioning and the Morse water maze.
Right.
But when it comes to humans, so I guess there's kind of like two different strategies that you could go about trying to study this phenomena. So the first one is to try to stress people out in laboratory settings. And that's the area that I'm a bit more familiar with. So this is things like the Trier social stressor task, where basically you tell someone, hey, they come into the lab, they think they're going to do some sort of like boring psychology study. And you're like, hey, just so you know, in 10 minutes, you're going to have to give a public speech on this really complicated topic. Or you're going to have to do some complex math that you probably don't know. And you're going to be recorded and evaluated on the delivery of your presentation. And little do you know that there's other people in the audience are trained to just look as irritated and pissed off and bored as possible in an attempt to stress you out. So that's kind of the situation that I'm a little bit, or that's kind of the methodology that I'm a little bit more familiar with. Is
wow. So you've done those. You've done those. That sounds like a very orchestrated experiment right there. I mean, it sounds it's interesting. So you actually have like people trained actors or whatever, people acting in the audience, like given a particular task, and wow.
Yeah. haven't personally done that research, but one of my really close colleagues has, and it is quite orchestrated.
Yeah.
I don't think that I would be very good at it because, like, I try to be like a very happy person, and I'm not sure that I would be very good at looking pissed off for like such an extended period of time. So yeah, no, it is quite orchestrated, and then usually. Oh, sorry.
I mean, it sounds like, you know, although it sounds orchestrated, it sounds like something that you could, through a bit of orchestration, bring in some ecological validity. In the sense of, you know, the other things like gambling, right? So that's something that is studied an awful lot, right? And the issue with cognitive neuroscience studies on gambling is that, you know, the typical kind of experimental protocol is you have whatever the small budget that you have to do your psychology research. You maybe give them that money to do a gambling task in the lab for an hour, right? Maybe they're in an MRI scanner, or maybe they're just in a room, right? But the stakes aren't high, right? So that you can study gambling, but you can't really study gambling in a lab in terms of like some of those particular critical features of like very, you know, high stakes, and essentially just because it's hard to do that at an emotional level and an economic level. But with that kind of, you know, social stressing scenario, that sounds like something that you can at least approach a more like realistic representation of the type of thing that you're actually trying to get at. Yeah,
so I think the key thing that you're getting there is like the difference between like internal versus external validity. So like the social stressor task that I was just describing is really trying to maximize your internal validity, because public speaking and doing math is one of those things that so reliably stresses people out. But on the flip side, the other way that you can study it in a little bit more of an externally valid way is just ask people how stressed they are. There's numerous different validated self-report measures for stress that you can use to get a sense like, okay, like where's this person at? Are they more stressed than the average person? Or as I'll get to a little bit of it later on in this presentation, are they more stressed than they were yesterday? And kind of thinking about those kinds of things. You can often just take advantage of ongoing stressors as a way to more ecologically, to study this in a more ecologically valid way.
Great. Okay, thanks for that interjection.
Yeah, I'm also going to jump in there quickly, just building off of kind of John's original question and where you brought it there, Ty. And looking at, I guess, this stress resiliency, stress sensitivity dynamic, and you had highlighted before that, you know, individuals that may be predisposed for developing a mental illness in their life may be more sensitive to experiencing burnout or experiencing chronic stress. Are there certain serious mental illnesses maybe that you're familiar with that have been associated with burnout, where maybe there wasn't a familial history of that mental illness and it was kind of largely caused by, maybe, or not caused by, at least strongly associated with the presence of chronic stress and burnout?
So the short answer is yes, and I'm actually got a full section on that a little bit later on. So if you want, I can hold this question for a little bit later, and then I'll be able to answer it with quite a bit more nuance and some better illustrations.
Please, for sure.
Sounds good.
Yeah.
Nice.
Yeah, no, so we're on the same wavelength, quite literally.
Mm-hmm.
So kind of returning back to the EEG side of things. So this is the area where I was doing my PhD research on when I met Shannon, which is trying to see if we can use EEG as a way to get a more objective biomarker on whether or not people are engaging their executive functions. And the brain signature that we're looking at is a medial frontal theta. To those of you who aren't aware of that, theta is a brainwave that's roughly 4 to 7 hertz. I was going to say 12 hertz, but that's in rats, so ignore that.
Oh, really? Oh, that's interesting. Rings a bell, but yeah, I've heard of that.
Yeah,
it's strange.
But one thing that's I think is really interesting about medial frontal theta is we believe that it originates from the cingulate cortex, or some people disagree with like the specifics of that, but broadly the medial prefrontal cortex. So we got this brain wave that's fairly circumscribed as far as like where you can measure it from. And you can see in this study that this was a review study where they looked at 3 different experimental paradigms, and they found that whenever there was some sort of impulse inhibition or surprise that needed to happen, you reliably got this activation within the theta range. So if you guys can see my mouse there, so it's like right there, this nice little hotspot that is reliably popping up as an increase in power, and then additionally is an increase in phase locking, meaning that you actually have the synchrony between your frontal parietal network and your cingulopericular network is increasing when you have this momentary need to engage cognitive control. And again, for this final one, you can kind of see its scalp topography where it's fairly reliably, you can see it over medial frontal sites. So this is the brain oscillation that I was looking at most extensively as a way to try to measure whether or not people are engaged in their cognitive control or whether or not they have the motivation to engage the cognitive control, since those are fairly interrelated. And it turns out that the key thing that my own research was able to find is that variability is really important. So this study, I think, does a really elegant job of kind of showing it. So what they did is they took a bunch of people from across the lifespan, and they looked at what was the phase locking within the theta range from those sites, and they correlated with the variability in reaction time on just a typical cognitive task. And what they found is that the more variability there was, the lower the phase synchrony in theta there was. So this means that you got this linkage between the variability in your brain waves and the variability in your behavior. And this is really critical because it means we can start to make some inferences about what the brain might be doing based on the behavior that we're observing in a relatively non-invasive task. So in this study, what they were doing is it was a meta-analysis where they had almost 10,000 people, or subjects, that they analyzed, and it was looking at people with ADHD versus neurotypical people, and just looking at what was the effect size between and in this measure of reaction time variability. So to those of you who may not have seen a reaction time distribution before, it looks like a lot like a normal distribution, but just with a longer fat tail towards the low end. And it's thought that those longer reaction times come from lapses in our frontal parietal network. A very colloquial term would be like a brain fart, where you're thinking, and then your mind just kind of goes blank, and it takes a second for you to respond. And that second is enough to start to add up once you start looking over multiple different trials. And what they found is that people with ADHD are much more likely to have these this variability in their reaction time to the point where it could actually be somewhat diagnostic. So this is how I illustrated there. And to those of you familiar with effect sizes, the difference between the two groups was 0.71, which is quite substantial. That's a fairly medium to large effect size that you can actually start using to make inferences on an individual basis. Which is quite impressive because there's so much variability between individuals. To have a signal like that that's pretty robust at the behavior level is quite impressive.
Is this across multiple tasks?
Usually these studies are done within one task. So usually it will last, I think, 10 to 20 minutes, depending on the particular version. I think the longest I've ever personally done a task like this or asked people to do a task is 20 minutes. But I've seen some studies where they'll have people do this for hours, so they want to really exaggerate that. Because the other thing is the longer you're doing the task, the more variability tends to pop up. So the variability does increase over time.
Okay, but this N equals 10,000 meta-analysis is over studies using just this one task, not
yes.
a range of different tasks that are somewhat similar that you get reaction times from.
Oh, I see the question you're asking. It was across several different kinds of tasks, but it was all like oddballs, Erickson flanker type tasks where you're just getting a reaction time. And again, from the work that we saw with medial frontal theta, they're engaging similar parts of the brain when it comes to that response conflict notion.
Got it.
So the reason, sorry?
The light blue, that's ADHD?
Oh, yeah.
Okay.
So the reason why I wanted to bring this up is this highlights how useful variability is as a potential diagnostic factor. So this is something that our app actually takes advantage of, is looking at ways that we can model variability. So this is a paper that I published actually just slightly before I met Shannon, if I'm not mistaken. I like how I keep using that as the reference for the timeline. And it was looking at how we can start using patterns in time series data a little bit more constructively as it relates to measuring executive functioning. So this is a little bit of a complicated figure, but the important thing that I want you to focus on is that the vast majority of studies only really look at this section of the equation right here. They're looking at overall mean level differences between groups or mean level differences across time. So kind of like pre-post. Whereas what I wanted to do was see if we could use multiple different types of temporal signatures simultaneously, and whether or not that would be more diagnostic. And this is we put into the 8-Bit Cortex app is these different kinds of metrics in our algorithms. And this is kind of where we get to the final piece before we get into the demo, is this idea of coupling. So you can think about, it's easier to see in this previous slide. So if you look right here, there's this red trace and then there's this blue trace. So you can see that they actually parallel each other quite quickly. So using this analytic approach that's outlined in this paper, you can actually measure how correlated those time series are across time. And that in itself can be quite useful. And up until now, we've identified these various risk factors for burnout, such as the increase in chronic stress, that variability in your attention. And now finally, we've got this idea of coupling, that two different things can be correlated through time. And if you recall correctly, the third feature of burnout that we're talking about was low trust. So the final thing that we can look at in trying to get an easy to identify biomarker burnout is whether or not these three things are really correlated together, whether or not there's a lot of coupling.
Ty, could you actually elaborate on those two equations there a little bit? Like I get some of it, but yeah, it's an interesting framing.
Yeah, so for sure. So basically the way to think about this is you have a time series of data and it's rocking around, and this could be literally any time series. For my dissertation research, I did this on medial frontal theta power, so using EEG data. I've done this with self-report data, which is what our app does, as well as measures of attention, which is what our app does as well. And the important thing is you get that time series of data, and then you look at what is the change to a successive time point. So what you start off with is you take your change from time point 1 to time point 2, and you make that the outcome. So you create a new array of change scores, and you regress those change scores onto your original values. And this forms what's referred to as a fixed point attractor. And it's basically a way to model homeostatic fluctuations. So the idea is that you have a set point that you're most stable at, and then as life happens, you get knocked around and you move away from that set point, but eventually you're going to return back to it ever so slowly. And this next term right here, the stability coefficient, that reflects how quickly you return back to that set point. So basically you can think about this as what is your overall level, and this is how much do you move around that level. And then if you have multiple time series, then you can get the coupling piece as well, where then you can be like, okay, how does stress relate to your executive functioning? If your stress goes up, does your executive functioning go up? That would be a positive coupling relationship. Or for an example, the negative one would be maybe as your social support goes up, your executive functioning goes. I think I got that mixed up. As your stress goes up, your executive function goes down. So that would be a negative inverse coupling relationship. Whereas a positive one would be as your social support goes up, so does your executive functioning. So that's kind of what's going on in this box right here.
Actually, it looks an awful lot like a kind of, well, it's a linear difference equation basically. So it actually looks a lot like a network models of neural activity that I work with day to day. You have your coupling coming in. So often that's like one part of the brain having some input from another part of the brain. Okay, cool. So you got intra-individual variability, and then your second one.
Yeah. So the other one is looking at longer term changes. So basically this equation right here is going to assume that you just have overall, you're not having any broad changes to your level. It might jump around a little bit, but it's fairly stable. Whereas this one allows you to model, do these dynamics change across time? So is it the case that at the beginning of the day, you have a particular set point stability and coupling coefficient, and at the end of the day, sometime later, do those values change? And this is a way that you can explicitly model that using a growth curve equation. So it's trying to model both individual variability and individual change at the same time.
Mm-hmm.
Yeah. So I go into that.
But the time scales. So you're saying you use this for arbitrary data, essentially, with different temporal characteristics. But I guess the time scale and the point, the kind of time scale at which you consider something to be dynamics versus something to be change in a longer term slow variable, that kind of matters here. So, do you need to decide up front? I'm looking at EEG, so slow change is on the order of minutes or on the order of hours, and like behavioral data that you're talking about just now is on the order of weeks, on the order of months.
Yeah, no, so that's a really good question. And I guess like my answer to that would be, it really depends on the theory and the phenomena that you're working with. So when I did this with my dissertation data, I was modeling the stability and the fluctuations at the trial to trial level. So that's like, seconds, because it'll take, 3 seconds for you to get to the next trial in an oddball task. Whereas the change piece, the longer term piece, that was over the course of the entire task. In this case, it was, in one case it was 15 minutes, another one it was 20 minutes. So just there's a relative difference there. But then you can generalize that to lots of different phenomena. So you can look at emotions over the course of an entire day, and that could be, looking at your variability. But then if you look at how those emotions change over the course of the week, that would be inter-individual change. And you can extend this out even further. You think about development. So like the ultimate kind of inter-individual changes are development. So we start off growing and then eventually start declining once we get towards the end of our lifespan. And everything else is just variability kind of around that trajectory.
Great.
Yeah, so overall, I'm a really big fan of this particular strategy because I think that it gives us a lot more information from data that we otherwise might be getting. Because again, most studies out there just look at mean differences between this condition and that condition, whereas this is actually trying to model what is the mean difference, what is the variability around that mean, is that related to other variables, and is that entire set of dynamics changing across longer time scales. So it's a little bit more of a nuanced way to try to go about things that I think could be really useful. And that's why we got this paper published.
Yeah, and you're not looking at, there's no standard deviations here, like that's normally when in this variability literature, which is huge, right? Especially in cognitive aging and cognitive psychology, that the metrics I'm familiar with there is more, you just take the standard deviation of the time series. That's the variability measure. You have a much more nuanced characterization here.
Yeah. So, and like, I want to start off by applauding people to look at the standard deviation, because like that's a step further than just looking at the mean, and that's giving you much more information. Kind of where this approach has kind of a one step up is you could hypothetically randomize the ordering of the data points in your EEG data, and you're going to get the same standard deviation because it's not sensitive to that change. Whereas because this is looking at the successive change between data points, it is sensitive to that. So the stability actually would completely change if we were to randomize that. So it gives you a little bit of kind of extra sensitivity information that way, but otherwise they're very conceptually similar. The fact the stability coefficient is going to be highly correlated with the standard deviation most of the time. Got it.
And is there a name for this framework? Like, is there a technical name? You said it's a growth curves. I guess it's a bit like a drift diffusion model as well.
not quite a drift diffusion model. So the most simple name for this model is called the fixed point attractor, and that's where just modeling the stability and the return back to the set point.
Right.
And then from there, you can start expanding it out towards other things. So this is actually like a composite between a growth curve model and that fixed point attractor. And then you can get even more complicated, where instead of assuming that it's a homeostatic relationship, you could assume that it's actually a cyclical relationship. So it's, there's a cycle going on, which you can kind of see that in like this, the data here, where, there's a bit of an oscillation that's happening. So there's lots. So this general framework is very expandable, and this is just literally the most simple way that you can articulate it. But it's very expandable and generalizable depending on what your phenomena of interest is.
Yeah, I can imagine some long-term oscillatory behavior would also be of interest in terms of people's response to chronic stresses as well. I mean, and even some mental health phenomena like bipolar disorder in particular springs to mind, right? That's basically a long-term oscillation in a certain kind of mental state.
Oh, 100%. That's actually one of the applications that'd be really exciting to see kind of moving forward, is because like there are certain conditions that do have this almost like this like state change, or like suddenly now your dynamics are fundamentally different. So depression and bipolar are good examples of that, where they're episodic to an extent where you can actually see those changes in relatively gross scales.
Yeah.
Awesome. So before I move on, so do we all feel like fairly comfortable kind of like what the ideas behind this modeling approach are?
I'm super comfortable. I don't want to bore everyone else anymore by drilling down, but I think this is a really interesting, I've never seen this framing, so I just want to kind of indicate that this seems like a very interesting approach to this question of variability and change. Really speaks to me, actually.
Yeah, so we're actually going to come back to these ideas a little bit later on when we do the demo, and then when I talk about some of the statistics later on. So we'll have an opportunity to kind of reconnect with this.
Good.
All right. So just kind of to overall summarize. So now I've got this sense where we've got changes in levels, changes in variability, as well as this coupling. And how I like to think about burnout is it's this congruence of all three of those factors at the same time. So you've got this increase in variability, you've got the chronic stress accumulating, and you've got your lack of trust or your cynicism or your emotional detachment is coupling with those other variables, so they're all kind of floating together. And that's when you're at the highest risk for burnout. And then just broadly to say a little bit about like the origins from this framework, it comes from dynamical systems theory, which basically argues that any complex system, like the human brain, has lots of different factors that are all interrelated and somewhat independent but loosely coupled with each other, and that these complex systems are extremely sensitive to context. And that's one of the reasons why I like this approach, is because it actually functions much more better in real world scenarios. So it tends to have much higher external validity, because again, you're measuring things through time. So you're able to get those multiple observations, and you can see like, okay, where is there consistency across factors? Where is there differences between context? And then those dynamics I was previously talking about start to tell a much more nuanced story about how this system is behaving within its broader environment. Okay. So at this point, we'll start off getting ready for the demo. So I've got the QR code up on here if you guys want to check out our link tree. Additionally, you can go to bitcortex.app. And so I'll pull this up myself, but I'll give you guys a couple minutes to pull that up. Let's see, can I just move this in front? Oh, success.
Quick shout out, seeing as you've got this Lorentz attractor there to the Nobel Prize in Physics, which 1/3 of which was for complex systems.
I think you're actually the first person that's gotten the symbolism behind that with the Lorentz attractor.
Well, it's where my head is, for better or for worse.
Okay. Yeah. So I'll start going through the demo then. So basically, I want to kind of illustrate how we can start using these principles when it comes to tracking burnout and what our app is doing in order to do that. But I want to start from the context of like this app is designed for people that might be experiencing some challenges with their mental health. So right when we go to the login screen, you've got normal stuff like being able to log in with your email and stuff like that. But for a lot of people that might be experiencing mental health challenges, what if they lose a password? If you think about somebody that has ADHD, that could be a barrier to them more effectively being able to use the app. So that's why right from the beginning, we want to have these third-party integrations. So then that way we can make it as seamless as possible for people to get on to using the app. And of course, now I'm going to have browser issues just when I started that. But here we go.
So let's kind of contextualize a little bit. So the use case here is the individual has heard about your service, grabbed the app, logging in, but like how are they? How do you envisage them kind of being onboarded? Have they kind of found you online, or have they had a recommendation from a friend or a doctor? Like what precedes them at this coming to this login screen?
So it could be a few different ways. So I'll talk about that a little bit later with our commercialization strategy. But kind of the first one is people just find us online at kind of like a B2C approach, where they would want to use this as a mechanism for being able to track their own burnout and kind of get a sense of those risk factors. Another way is we're really hoping to be working with HR departments and putting this within companies as a workplace wellness management tool. So in that case, they would probably be given access to the app through their team leader or through their HR department. And then we also do workshops related to health and wellness and burnout management, where we'll be using this as an interactive learning tool.
Got it. Yeah, I know that unfortunately we know a little bit that Crowdcast kind of abuses browsers a little bit, so
I was about to say this is taking way longer than it typically does.
Yeah, but I think you had it up in the green room before, so
yeah.
So we've seen this coming okay. Yeah.
There we go. Now it's going. That just took an eternity. Okay, so now hopefully everyone else is kind of logged in along with us. Oh, this is loading up super slow. Crowdcast is really doing a number on us.
Maybe turn off your video.
Yeah.
Okay. Let me stop sharing for a second in case that can allow me to fix things up. Oh yeah, the moment I stop sharing, everything pops up. Okay, let's see how I can turn off my video there. Okay. Hey, you can no longer see me, but now I can screen share.
So much for your tech support.
I was not aware that was a feature. So your screen share is not available. Okay, Ty's going to reconnect.
There we go. Let's see if that works out. So.
Okay, we have a screen share.
Okay, and you guys can see it? Okay.
Yep.
Yeah, so this is what the home screen starts at. So this is a progressive web app, meaning it's a website that can be accessed and looks like a app from a smartphone. So I just tried to change the sizing of the screen so that it more resembles what it'll look like on a smartphone, despite the fact that I'm on a desktop. So you can start by doing a check-in, which will basically run through the main area for doing that data collection. This is going to be super slow just because we're streaming.
But this, so this is something that we can get to from the link that you shared, and is that like a demo platform or?
That's right. So we are looking for your feedback.
Yeah, so everyone can follow along with us.
So you would like us to be with you, like logged in right now, doing the same thing?
If you would like to.
Well, I'll definitely suggest everyone else does that. I think I'll try and keep my eyes on the prize and
No
see us
worries.
through. Yeah.
You can check here, and if anyone has feedback, we're happy to hear it, as we're continuing to develop this.
Good. Thanks, Shannon.
Yeah. So basically, again, the function of the app at this point is just to start collecting those individual data points, thinking about what is the easiest data that we could collect that can be the most useful given that time series analytic approach. So we just ask people to rate a number of their individual emotions. So I did some public speaking, so I'm going to rate myself as a bit more worried than usual. I didn't sleep the best last night, so I'll put a little bit more tired. I'm really focused right now because I'm trying to, do a good job for this. This has been a lot of fun. I'm pretty happy, just kind of going through. Really grateful for the opportunity, trusting people, not technology, and relatively low stress. So those are all individual emotions that we can use as a raw proxy for burnout. And then on the next screen, we can ask people what are some different things that they've engaged in. So for example, did you have a positive social interaction? Have you engaged with technology? We'll click yes, because I'm obviously on a podcast right now.
Going to be highly correlated with negative emotional experiences. The technology one.
Yeah. Okay. And then this is kind of where one of our other really key innovations coming from my research is how do we collect objective cognitive data. So we have this game called QBrush, which basically recapitulates a lot of the really important features of a reaction time task. So you just try to dodge those obstacles, and if you can, collect those power-ups.
It's kind of like Super Mario Brothers from the 90s. So sliding along.
It really is.
And you start having so much fun, you forget that it's actually measuring your cognition over time.
I was going to say, it was like fun. I'm enjoying just watching.
Yeah, way more fun than filling out a pen and paper assessment that you'd normally do.
Uh-huh. So what's there's reaction times there. Is it just reaction times, or do you have some kind of predictive learning component? What are the elements of the task there?
So we don't have the predictive learning component just yet. We need to get more data in order to start building that in. So it has a basic staircase algorithm for difficulty. So based on did you get the last X percentage of trials right? If so, then the speed increases a little bit. So the idea is that you're always being tested approximately at your limit. And this has the one benefit by making it more engaging, so that way this tedious task doesn't actually get boring, because the things are always flying at you in a more appropriate speed. And then it logs the reaction time for us to really get that sense, what is the variability in reaction time. And then you saw that there is those different colors and those power-ups. So a dual tasking component is, are you able to not only dodge those obstacles, but catch the correct power-ups of the congruent color. And then for that, we can start making a whole bunch of inferences about different kinds of lapses of the executive functioning. For example, if you are agnostic to color, we will call that a set loss error, meaning that you're not paying attention to the full set of instructions. Or if you do the wrong power up and it just recently changed, that's a different kind of error that indicates a perseverance error, meaning that your brain hasn't shifted over to the new rule set. So trying to bake in some of those features of more classical neuropsychological tasks.
What about, just to throw the probably difficult question in early on, Ty, learning, right? Because you're looking for, as you said, long-term changes associated, and which are associating with burnout in an interesting way, but people will get better with some kind of long-term trend on this task. And I guess you're introducing novel components, and probably you're going to line up more than one task. But what do you have a formulated evaluation of that?
Not so more formulaic at the moment. So basically, we do know that there is going to be a learning curve, but at a certain point, the literature suggests that people kind of plateau when they get to like a stable level of performance. So from the dynamical systems perspective, basically you wait until people get to that stable level of performance and you just kind of ignore those first few trials. So you have to kind of let the system run through a few iterations in order to get to like what its true functionality is. And then from there, if you see a fluctuation up or down, presumably it's related to something of importance rather than, oh, we're learning today. That being said, my score is almost consistently for this demo between 15 to 17.
Well, that would be very supportive of your point and about trends and stability.
So kind of the final piece that I'll show you guys with this demo is now we've gotten to the analytics page. So you can select those various icons that we've tracked right here. And assuming Crowdcast allows it. Oh, there we go. Yeah, so it'll actually plot those out so you can see what are the patterns in these variables across time. So then you can see like, okay, there actually was a change in like how focused and tired I was. This is just like fake data from me doing demos, so like try not to interpret it too much.
But that's an example of when you were tired. Like what would be when would you plot two things? Like how would those be chosen?
So it's a little bit more clear for the other variables. Once my browser catches up. Oh, are you guys frozen? I'm frozen.
We can still see you.
Okay. There we go. Sorry, my browser took for a second. So remember how I checked off technology?
Mm-hmm.
Let's have that actually click this time. So it'll actually start showing like at different occasions when you interact with technology, and you can start to see whether or not there's any patterns that start to emerge. These variables aren't actually showing a whole lot of patterns, so maybe these aren't the best ones. So let's uncheck how tired you are, and let's check out worry. So you can see now there's a different pattern that's going on where now it looks like your worry and your focus are a lot more strongly correlated than how worried and tired you were. So this graphically displays all the data. And then the analytics that I was previously showing, those get run in the back end. Once browser catches up, there we go. So now it actually gives out those parameter values. So what is the set point, what is the stability, and then what is the coupling? So then you can start looking at, okay, how are these numbers changing over time? So for burnout, you could look like, okay, is my focus starting to become correlated with my stress levels? And is my focus got a much higher level or much higher variability than it previously was? So then you can start to see, okay, how does the graphical depiction of that data actually correspond to the stats? So what we're working on right now is trying to find ways to make this more intuitive for people to get that information from. Right now, our MVP logic is we have an embedded YouTube video.
It's a work in progress.
Yeah.
I am absolutely just delighted beyond description that you're showing this information. Like you had a few slides back, you had that equation, you're like, this is the thing, and then a few slides later, and here we are, app demo, and you're like, these are the parameters of the equation, this is the number, this is the thing. I'm just thinking about this compared to other wearable apps that will give me like this absolutely opaque, like completely ununderstandable, no, like fluffily described metric of like focus. Sorry, Neurosity guys, or the thing that Muse tells me, or even the things that kind of sleep, some of the less clear sleep variables, the sleep tracking things. The general point is, you get metrics and you get kind of feedback numbers, right, from this type of technology, but it's just completely unclear like what it means and whether it means anything at all. So yeah, wow, you had like coefficient labeled with numbers. As a, again, person who's kind of in that space, like that's a nice thing to see. Like I can understand it.
Well, at the end of the day, what we want to do is empower people to be able to use our app so that they become like mini scientists for their own mental health. Mm-hmm. So then that way they can understand, like, okay, if I'm seeing the numbers popping up in this way, it means I'm heading towards burnout. I should do something about that. And have them be able to internalize that process. And the more transparent that we can make it so that people can understand why those numbers are important, I think will ultimately be the better.
Mm-hmm.
So... And this is where Shannon was saying we're going to have a lot of iteration. Like, okay, what is the best way to actually tell people that? A YouTube video is probably a reasonable first pass, but it's obviously not the best way.
Well, I think a mix of links to short videos or embedded short videos is the right way, actually, to best kind of most information rich and least cognitive load.
Yeah.
Yeah.
So I've still got a few more slides if you guys would like, kind of to flush it out, because then that'll lead into the commercialization strategy, where we can start kind of diving into some of those other details a little bit more with more nuance.
Yeah, great. Super interested to hear these things.
Yeah.
And to our audience members as well, like please throw your questions in the chat. I think we've had a really interestingly back and forth discussion so far, so let's we can keep that going and bring some other sources of questions.
Yeah, I'm really excited to hear about the commercialization as well. Just wondering before we do move on, like any thoughts of also bringing in some of the more kind of qualitative information, things like in that day, for example, what led me to end up getting that number, that coefficient, so that I could start to look backward on some of the things that I'm experiencing in my personal day-to-day that would associate with those changes?
Yes, absolutely. So we do have options for entering some journal notes if you want to write a couple of things that happened that day. There's also some prompts. We are also interested in finding out from the people that tried today, what would they like to see? What types of qualitative information would be helpful for them to help empower them in improving their mental wellness?
Nice. I'll say just adding on to that I was playing around with the demo version a little bit before we started this call, and even in the time spent on doing the Likert scales or the sliding scales or whatever it was to assess my own state, I learned so much about myself. Like I'm certainly going to implement this in my daily practice and can't wait for the app. Sign me up as a beta tester, please.
Oh, that's awesome. Thank you so much.
Of course. Thank you.
Thank you, Brian.
So just kind of a quick recap for how we're trying to go about measuring burnout. It's a combination of a few different things. And this is kind of where the science starts to meet the business a little bit. So we've got these cognitive tests in order to get objective data about how your attention's behaving. We have the self-reports in order to get quick and easy subjective data. But critically, what we're looking at is temporal patterns. So right now we've went through kind of like our first pass at that algorithm. But as I was previously alluding to, we've got lots of ideas on how we can expand this out subsequently, add in machine learning, make the form a little bit more complex to get more factors in there, incorporate some of the subjective stuff. So we're really just like the MVP stage right now, kind of the sky's the limit for how much we can start to flesh out that burnout tracking algorithm. So kind of getting back to what I was saying earlier, our strategy has a few main components. So the one thing is the gamification side of it. So because Shannon and I really wanted to make something that was useful for people that were struggling with mental health, we wanted to use gamification as a way to get people more engaged and have more longer term usability from it. So basically, based on the meme here, if you have an app that has boring UX, people with ADHD aren't going to want to use it because they're going to get bored with it right away. And when we did our initial market research, that was one of the biggest reasons why people don't continue using self-help apps in any capacity. Because after a while, it's either too general or it gets too boring. So the hope is that our gamification strategy can help us build up user attention, be able to build that intrinsic motivation, and ultimately start to facilitate behavior change. So that way people can actually change the way that they're going about their day-to-day life for the better, based on what the data suggests is good for them. Shifting up a little bit, a little bit of research. So the statistical approach that I used to arrive at this model is called mixed effects modeling. Basically, it allows you to do anything that an ANOVA will do, but probably better. And what I really like about mixed effects modeling is it allows you to model both within subject variability as well as between subject variability simultaneously. And then what I have highlighted in the equation here in blue is the interaction between those. So that is to say, how can you classify people as type A, type B, whatever you might be interested in, and see how their patterns differ. So that way you can use those patterns as the actual individual difference indicator itself. Use that as the biomarker. So this is a statistical approach that I'm very fond of, and I highly recommend that people learn a little bit more about this. If you're used to R, it's fairly easy to implement. You can do anything in a repeated measures ANOVA using this statistical approach, except it's regression-based and much more stable and more flexible and generalizable. So just give a quick plug-in for one of my favorite methodologies here. And then, is my slide going to advance? There we go. So then kind of going back to our commercialization strategy, more or less we've got a two-sided market that we're working with, where we want to get this app into the hands of individual people that might be struggling with their mental wellness, so then that way they can use it for their own individual benefit. But given that burnout is so heavily predicated on what happens within the workplace and how big of a source of stress that is, we also want to be working with employers and HR professionals and business leaders in order to get this app into people within the workplace. So then that way we can offer the company analytics related to what the overall wellness of their workforce is, while you have the individual employees within that company doing individual actions to better their own wellness. So that we've got both a bottom-up and a top-down approach. So this allows us to use our app as a learning aid within the workshops. I was saying is one of our mechanisms for onboarding people. It allows us to use this app as a consulting tool for doing data collection. So that way we could give those companies, the feedback like, hey, did you know that your workforce is really close to burning out? You might want to do something about that. And then the beauty is that these two strategies can actually feed each other. So the more people that we have using our app from the B2C side is going to eventually, once we have the machine learning algorithms hooked up, is going to make those algorithms more robust and resilient. So then that way we're able to do better B2B services, which in turn allows to have better individual user experiences. So this way we have both sides of our market kind of feeding each other. I've heard someone call this the B2B2C route, which I think is just starting to get needlessly jargony, but hopefully you guys get the general idea. Shannon, did you want to say anything else on this while we're here?
So an important consideration for this is that the individual user, their data is private. It's not shared with their employer. No one would want that. However, the employer is able to see trends of their overall workforce, so they can see when things like burnout are becoming a huge risk, and that way they can take those preventative measures and reduce their overall cost of burnout, for example, in the workforce. We've just started using this as a learning aid for workshops and are finding that it's working quite well. And the freemium model really comes from Ty and I wanting this to be a social enterprise. We want to benefit society. It's not something we're here to make a ton of money from. We just want to empower people to be able to take more control over their mental wellness, as we've seen family and friends suffering throughout the pandemic. So that really drives us with this project.
The question of not giving individualized data to employees is an interesting one, because I'm thinking for small businesses, like very small businesses, if they wanted to get on board, then at some level, people become identifiable, like n equals 2, n equals 3, right? So again, like if I don't know if you've thought much about this, like if you're making a big thing of the this anonymity aspect, but does anonymity have a flaw in terms of the company size from your point of view? A flaw, FLOOR.
For sure. There's definitely other similar applications that we've seen in organizations. For example, employee surveys. I've seen the minimum start at 5 employees. Smaller than 5 employees, they won't provide any trends for that department.
Right.
So there's definitely considerations there.
Yeah, because exactly. Yeah, as Shannon was saying, the last thing we want is for a manager to be looking at the data and be like, this data point is really unproductive and they're experiencing a lot of burnout. It would save us money if we just fire this person to hire someone that's more effective at. That's the exact opposite we want to have. So for exactly the reason that Shannon was saying, yeah, kind of right now 5 is our floor.
Got it.
Just kind of the last thing that I want to briefly touch on is how we can start thinking about mental health challenges as, rather than being a liability, as a bit of an opportunity, as an asset, and that there's just different kinds of trade-offs. So earlier on, I was saying how, from an evolutionary perspective, we've got these individual risk factors that go towards burnout. And actually in utero, we're trying to predict what kind of world we're going to be growing up in so that our brains can adapt accordingly. And this is where the individual differences for risk factors for burnout come in. So Brian, I think this is the question that you brought up earlier that I'm now kind of coming full circle in order to answer at. So basically, there's a lot of data suggesting that when people experience a lot of adversity in their early childhood, usually within the first 5-7 years or so, this highly predisposes them for a number of different mental health conditions. But ADHD is kind of one of those anchoring diagnoses that in and of itself is a risk factor for other mental health conditions. So the reason why we thought that this was interesting is that while ADHD can be challenging for a number of people in certain ways, it also can be really well suited towards entrepreneurship. So we can think about this overlap between someone's genes, which they can't really change anything about, and their early environment, those factors, and then their current work environment, and how those all kind of predispose people for individual levels of burnout. And we know that if people have a family history of mental health challenges, there's some sort of adversity within their early life experiences, and they're currently under conditions of stress or not getting enough support in the workplace, they're at a much higher risk for burnout and just mental health conditions in general. So the way that we can kind of think about this is when it comes to ADHD is we've got this curvilinear relationship between their ability to engage their executive functioning and what their baseline level of dopamine is. And where we would all like to be is in this spot right here, where we're nicely at the top of this, where we're able to engage our executive functioning perfectly, but we don't always stay here. Sometimes we're in a really, really boring lecture and there's no dopamine to be found. And accordingly, we're not going to be as focused. And it can also go on to the flip side where we can have too much dopamine, and this can actually start to trigger some anxiety and similarly impact our frontal parietal network's ability to properly engage. But then we have people with ADHD where they tend to be chronically at this lower level of baseline dopamine, where they've got that combination of genetic and environmental risk that predisposes them to not be able to engage with executive functioning as easily as some other people. And this can often be viewed as a deficit, as a weakness. But what we would like to try to suggest is that we can actually look at these strengths that people with ADHD might have. So given that they come from those experiences of early childhood adversity, people with ADHD are often highly stress adapted, meaning when stressors happen, it doesn't phase them nearly as much. They tend to be a lot more resilient to that because that's literally what their brain is adapted to trying to work within. They tend to have a much higher risk tolerance. This in many ways potentially can be a negative outcome. But if you think about the specific situation of entrepreneurship, this is actually a huge benefit because when someone's starting off a new company, being able to take those risks can really pay off, even though it might be somewhat more maladaptive in the general population. And again, thinking about the stress adapted piece in an entrepreneurial setting, it is highly stressful. So again, you've got this group of people that actually have a lot of the characteristics that allow them to thrive in that. And then kind of the final piece, and this comes from some of the work by Bruce Ellis at the University of Utah. He's actually shown that people that have these early adverse experiences, they tend not to be as good at dedicating their focus on one particular task, but instead are much better at rapidly switching between individual tasks. So this task switching component. And if you've ever been involved in a startup from the beginning, you know that you have to wear a lot of different hats. Some days you're going to be doing your product development side of things. Other days you wear your marketing hat, and you have to constantly be juggling all those different things. But people with ADHD have somewhat of a unique advantage for being able to balance that particular set of duties in many ways, sometimes compared to other people. The one downside, though, is there's actually a lot of research suggesting that people with ADHD really struggle with time management. And this can go down to like very basic neurobiological things, like just being able to estimate like reliably how long a minute is. So this suggests that if we give people with ADHD the proper administrative support to kind of counteract some of the weaknesses they might bring to a team, they can be really beneficial for the team overall. So this is the final piece we want to try to start changing the narrative around mental health within the workplace, is to stop trying to think about these people as liabilities and start trying to think about them as assets that just need a little bit of extra support to shine to their fullest potential. So at this point, I'm cognizant of the fact that we've only got 15 minutes left. So rather than kind of going through these individual steps, let's stop sharing and just go back to conversation.
Well, thank you, Ty. This was, a real roller coaster, and obviously we had a lot of conversation along the way, which I think was exactly the right way to do it. I have many questions, which so I'll choose carefully. And Brian, you have a think about kind of what themes you might want to touch on here as well. But basically, I'm thinking things on the business development side and things on the technology side. So I'm going to jump in first on the business development and just kind of. I'm curious. Okay, so where are you at in terms of the trajectory of the company, and so like what is your next milestones, and like what milestones have you hit already, and what are the kind of important things that you're moving towards, and also what's your key strategy? What are your how are you kind of aiming to differentiate yourself in particular in this kind of general area where I feel like there are a lot of players coming through in this kind of apps wellness space increasingly. So do you want to hit on those two things to start with?
You're right. You're right that it is becoming more crowded, this space. So that's why we're going for a niche strategy and focusing on corporate burnout, as it is quite topical currently. As Ty said, there are many other applications. There's other places that we could play with this technology. But starting with burnout, making sure we get it right there. Our next steps are looking at clinical testing with the algorithm, checking that is it actually working in the way that we're intending, and doing a beta test. So anyone who's able to help test out the app, give us your feedback, we super appreciate it.
Nice. And if I can build off that, I'm also super interested in looking at your commercialization of it at that enterprise level, and particularly when scaling and you're dealing with, I guess, hopefully dealing with like many different companies with different kind of work cultures, and so can you expand a little on maybe like the kind of the vision? Like, is it that your users are kind of logging in for the day and they're first prompted in their schedule the need to use your technology to report to their higher ups or something, and then is there a flag that then the higher up would bring to the user, and how does that work in the overall, I guess, workflow that we know to be work these days? If that makes sense.
Yeah, so I guess I could take that one. So basically for like individual people, employees that would be using the app, we would basically want to treat them like we would a typical like B2C customer. Like, I mean, their data would anonymously in aggregate go towards their supervisors for that overall. But basically what we really want over the next like several months is to refine our gamification strategy and our UX so people actually enjoy using our app. So then that way we don't have to like hound people to do it. One of our main competitors out there, I'll keep it anonymous, but like their strategy is basically what you just said. Like they get surveys on a daily to weekly basis, depending on, you know, where in the sales cycle they're at. And getting people to fill out surveys is difficult. Survey burnout is quite real. So we're trying to differentiate ourselves in that we're not trying to beg people to use our app. We want people to just inherently enjoy using it, to kind of separate ourselves that way.
Yeah, I guess, yeah, it totally makes sense. And having played around with the demo, like I really did like the interface. I like the aesthetic, like the design is super appealing, attractive and whatnot, as I kind of touched on before. But I guess I keep coming back to this idea of like looking at time spent, right? Work hours. You're basically having to convince the company that their employee should be spending that time on their day. So you have to convince them essentially to sell them on the idea that there's this need for it, right? And so I feel there's some companies, and maybe this is my just like pessimistic approach of looking at this, that some companies may not value that on the day-to-day over, you know, spending that 30 minutes, 15 minutes or hour or whatever it is on some of the things that they need to get done in their day-to-day work, right, towards their, I guess, revenue generating mechanisms and whatnot. So again, this is not my forte. I'm just trying to feel out how you capture the largest market, considering many different enterprises out there that are all experiencing burnout, presumably.
For sure. And it won't fit every corporation's culture. You'll see that the app definitely has that nostalgic kind of 90s feel. We're going with a little bit more pixelation. It'll definitely appeal more to millennials and Gen X. And so it's going to fit some users, but not all users for what they're looking for. And we are really cognizant of that time limit. So we try and make the daily entries 5 minutes or less, a very quick sign-in part of your day. Maybe something while you're drinking a cup of coffee in the morning. Because you're right, if it's too long, corporations are going to say no.
Yeah. I mean, you could probably link this all in with like performance evaluations and stuff too, right? So you're getting some sort of like automated sense of how you, cool. Yeah, totally.
Are there any models that you're going for? And it doesn't just need to be on the kind of specific like corporate burnout aspect, but just on generally in terms of the, you know, app design and that kind of app form factor. Like, are there... for some reason, I'm thinking it's not exactly the same space, but you know, Headspace is kind of an app and a kind of company that, you know, they kind of came in with a thing without necessarily, just making it something that people can do, right? That's like really the sense you have when you use that app, is like you turn it on and it kind of it's nice, right? Are there any other things that you've been looking at as examples?
We looked at Duolingo in our early days, and we received a lot of feedback that people said, absolutely do not make it like the Duolingo owl. Stay away from owls, absolutely. And even like the text notifications at the top where it says like, hey, you're running out of time, or hey, you haven't done this. We're trying to keep it more of a positive interaction. So that's
that owl is the most passive aggressive, or just explicitly aggressive. Yeah, that owl gives me a lot of flack.
Yeah.
Yeah.
Rightly so as well.
I think since we started on this venture, we've had a few different pivots. So originally we thought that we're going to be a video game platform where you just play the video games and that's how you collect the data. And then like, oh, maybe it's going to be more of like a journalings type app. So I think Reflecto is actually like a really big inspiration for the developer that's been working on this quite a bit. And then Headspace has also been like another inspiration because again, like they've got all those really good embedded mindfulness exercises. Mm-hmm. So I say like those are kind of like the 3 different broad source of inspiration, like apps of that sort, and we're kind of starting to be in like the overlap between those.
Yeah, I think that's a great idea. I don't feel like there's a really clear model that you need to follow directly, right? You kind of take the elements of things that seem to work, but yeah, also go with what makes people feel good, not what makes them not feel good.
Not passive the comments.
So, Brian, have you got any more questions on the business side? Because I might turn back over to algorithms briefly next.
The only other thing that I really wanted to talk about was the last point there that you ended on, really was looking at how, I guess, to make the work experience congruent to those individuals, to neurodiverse individuals. And you know, I think about this a lot in my day-to-day and whatnot, and I always come back to this idea of like, are we going to end up screening individuals and then trying to like triage them or stratify them into different roles within the organization, or like, you know, try and change the nature of work as much as possible to fit their needs? And there always seems to be this like level of incongruency. And so I was really happy to see that you mentioned it, and I'd love to get your sense of just that vision generally, and then of course how that relates back to your technology and the burnout, you know, being able to, I guess, assess the performance and everyone's states and whatnot.
Yeah, no, absolutely. That type of thing is very concerning. I can see doing personality assessments at the hiring stage, but punishing someone because they're struggling because of an organizational structure kind of challenge, I struggle with that. And that's one of the things that we're trying to stay away from. I know that there's lots of tone detecting technologies that are becoming more popular right now, where your employer has an overlay app, and they're looking at the tone of your emails that you're sending, and they're seeing, is it more negative, is it more positive? Hey, this person's a red flag, we need to recommend EAP, employee assistance programs, or whichever to them. Wow. That's the type of thing that we say, okay, yeah, you can punish people, but you're not really helping them. So we're coming at this as a way that you can work on yourself, and then at the high level, the organization, they can see, hey, maybe we need to add some extra things into our benefits program because there's something that's not fitting here.
Also, would it be able to detect my like ironically abrupt tone, or would that not get picked up?
Indeed, anyone with a dry sense of humor, it's worrisome for sure. Yeah.
Yeah.
Yeah. I guess just to quickly touch on the other point that you brought up, Brian. So I think one of the things that we do want to try to get across is that people with different mental health conditions, they can be assets in particular ways. So there might be a little bit of triage into, you know, what is a role within the company that, you know, best leverages their strengths. Like I've often joked, like once we grow to the stage where we need a compliance officer, I really want that person to like low grade, have some anxiety, because they're really motivated to be risk averse and not have those negative outcomes happen. So they're going to be intrinsically a lot more motivated to, you know, do their job well, just based on the way that their brain is wired, in the same way that someone with ADHD can, you know, really thrive in an entrepreneurial setting. So I think like there's ways in which companies potentially could change some of those broader structures, have a little flexibility, like Shannon was saying, to better accommodate these people, rather than, oh, you're not succeeding. Bye.
I liked Kathy's comment in the comment section about grouping people by personality type. I used to work in a pool of analysts, and they definitely did that to us.
Yes, I've heard whispers of this. I've never personally experienced it, but interesting, very interesting.
Great. So and we have about 5 minutes left. So as I said, I think I have a few other questions on on the numbers front, and then we can wrap up and thank our wonderful guests and wish everyone good night. So, okay. Well, first thing, I just want to somewhat repeat this, or this sentiment may have been clear before, but if someone had just said to me today, oh, there's this wellness app company that are like using dynamical systems modeling to track whatever, I would have been like, that's the coolest thing I've heard all day. That's the coolest thing I've heard all week or month. So, and I didn't actually realize that or pick that up initially. So that was just a pleasant surprise to me, hearing about the what's under the hood in terms of your approach. But it's really fascinating. It's really fascinating scientifically, and I think it has a lot of value from an applied side. So, two general questions I have, question comments. First one is when you're grabbing those coefficients, right? So I think you were doing that like per metric, right? So you were grabbing, you getting people to click on those 7 or so things, and you indicated that you want to kind of expand that, right? You want to maybe have like a diary or some other probably like custom list of other things that you're kind of pulling in that information from. So at some point you're going to have a kind of a multivariate, you already do, but you're going to have like a highly multivariate data structure. So it makes sense to, rather than compute those coefficients on the variables individually, to basically do some dimensionality reduction and then take the first component or the first few components, say, and then try and find some kind of variables that move together, right? And then just calculate your coefficients on that, and then you just need to come up with some kind of interpretable interpretation for what those latent structures are. So have you looked at that yet across the metrics that you have yet? Because I imagine some of those things, they really do all move together. Like some of them go up together, some of them go up and the other one go down, right? Like, is there a low dimensional loading pattern?
So that's a really good question. I'm going to have to disappoint you by saying so those kinds of analysis are really data intensive, and we just don't have enough data to start looking at that just yet. But that is something that I've thought about. One of my mentors and supervisors at Utah, he pioneered a lot of different aspects related to the statistical approach. So there are ways that you can basically do that dimensionality reduction. So then that way, once we get the sentiment analysis in there, we're able to pull from like Google Health, like really beef up our algorithm. At some point, it's going to be too unwieldy to just be like, oh, here's how your heart rate variability in the morning is related to your burnout in the afternoon. Like, no one's going to pay attention to that. So we're going to have to do some sort of like dimensionality reduction in order to make it interpretable. But that'll be a next stage once we do have enough data in order to do that. Because I think for that, we'd need at least hundreds, if not thousands of people. And critically, we need to have sustained usability. So we need to have people using it for at least 3 weeks on a daily basis in order for those algorithms to even start running. Right.
Yeah, that comes to one of my next questions, which is just the general vision, if you have one on the analytics side. You mentioned kind of pulling in. I guess this is going to be kind of critical, actually, is like having some additional, essentially like third-party data sources to make the tracking more automated, right? So you kind of don't have to lean on people so much to like input so much information. But yeah, like, is that something that's, do you have a roadmap for that, or just a kind of loose idea of where it would be the ideal place in a few years in terms of the data that you're pulling in over and above just a few items that you can get people to score on? And then what's the, you mentioned a little bit like machine learning. Well, what's the, how would you go about trying to amass those data sets? Right, because there's going to be a little bit of give and take. You're going to have to kind of get stuff out there to get the data, to build the insight, to get the product and the value, to get it out there further, and so on. So there's that cycle that you need to try and facilitate as well.
Yeah, so that's a really good question. So basically, this is kind of where like the two-sided market comes in. So we need to get quite a few people using our app in order to collect like on the raw individual items in order to start getting a sense of like how that data starts fit together. Because basically want to do that dimensionality reduction analysis on the data that we're already collecting. And then once we have a sense like, okay, what is like the smaller number of variables or constructs or dynamics that seems to be most important, then we can start plugging in those extra data sets, because then we're working with a more refined data space. So that I think we won't be in a position to implement until at least next summer. But that's actually where what Shannon just posted in the chat, one of our other strategies is we're doing educational workshops to try to teach people about burnout management and how to start thinking about mental health conditions from this trade-offs approach rather than this deficit approach. So we're hoping that that'll be another way that we can get a lot of people or more people using our app in a relatively short time frame. So that way we can, first of all, get the beta testing data in order to iterate our UX, but then along that entire way, be collecting the data necessary to be able to run that analysis. And then the developer that we're working with, he's really eager to be incorporating the broader data science side of things. Whereas like right now, we're very algorithmic in the way that we're approaching things. So
yeah,
I think that's a, oh, sorry.
Oh, and similar to employers, we cannot see individual users' data. It's all private, just for yourself. And we'd love to see some of the people here at our webinars later this month on burnout.
Is the data, would it be kind of fully accessible? Like, could I download all of the things that I put in and even the things that you estimate?
That is something we're working towards in the future. Currently, we don't have the download as PDF option available, but with GDPR rules, that is something that you should be entitled to. Is your own personal data, for sure.
I mean, it's also like, I think it's being a fruitful part of the business model, or at least the kind of development model for a number of other companies. You know, like Aura have a very usable data access model, and they've done an awful lot of like large studies and engaged with a lot of scientists and companies, because it's just so simple. They just give you this tiny CSV file, because they boil it down so much, and it's trivial to download, and it's trivial to do analysis on at scale. So I feel like having something that you can hand to people with some kind of minimal API level access probably will help you move forward in that area.
Aura, thanks.
Yeah. The Aura, I mean, there are a few ways to grab the Aura data, but the basically like a single night session is I think it's a CSV file, or maybe you get it in a JSON file. There's probably different formats you can get it in, but it's it's a couple of kilobytes.
It's a spreadsheet.
Yeah.
Yeah.
It's a couple of columns with like, but it's just a string. It's like maybe there's like 10, 20 variables, and they're just like character strings. They're not even kind of columns. It's really minimal, but it represents the endpoint of a quite involved analysis pipeline, because they get a lot of data, they do a lot of stuff in it, they boil it down, and then they give you this small thing that summarizes a lot of things really compactly.
Yeah. That's beautiful. That's how it should be. Easy to download, simple, easy to work with on the other end. Definitely a goal. Yeah,
and I think in a similar space than you, in the sense of like looking at trends in that case, trends both obviously a sleep trajectory is a time series that has certain trends, but then there's the longer term trajectories in your sleep trajectories that are also people want to track.
Yeah, no, you're getting into kind of where we want the business case to go, and we just need to build up the technology so we can do the science in order to have faith and confidence in that business case.
Yeah.
Because again, from a science perspective, as Shannon was saying, we need to validate all the things first. And for me, like, I think it's really important before we can give people the nice streamlined PDF file or, CSV, is to, manually go through it, run some stats like offline first to really get a handle on how the data looks. So then that way we can be prepared to give companies that kind of data, being much more understanding about it. And then from there, we can turn it into an API and automate it. So it's always kind of do things more manually until you understand it, then automate it and make it easier for other people to integrate and work with.
So do you have plans or ongoing work that's actually running studies and doing some scientific work to, grab this information and really study it in a couple of hundred people? Is that something that's like a part of going on right now, or something you're like actively trying to pull together?
Yeah, we're currently part of the Spark program at University of Calgary, and that's helping to connect us into W21C, which is where we can do the greater testing.
Right.
And then we're applying for different kinds of grant opportunities right now. One of them is actually to, with the U of C, kind of roll out our workshops to the student population and slowly start scaling them up, so then that way we can be acquiring that data. And start testing, like, okay, does it actually work in this situation? Does it stop working if we automate things too much? That kind of stuff. So those are definitely plans that we have up and coming.
Is that part of a financial plan or business plan? Like, is a grants model something that you have like penned in as part of your early business plan, and is that something that companies? I'm kind of somewhat aware, but not with a whole lot of depth, that's something that a lot of startups lean on hard, right? They lean on incubators to provide resources, and they lean on grants to provide resources, and they kind of lean on government opportunities in a way, and governments like that, so that's a thing. But is that a thing for you guys, like explicitly in the kind of multi-year plan at this point?
It is part of the mix. We've also raised money through competing in different events. Some of our earliest funding came from one of the MIT hackathons that we won, and we got some AWS credits from it, and little bits of resources from different areas like that. A lot of hackathons to try and get little bits of money.
Wow.
So we are quite efficient with working with very little money. So when we do get the grants, or we get little resources from the community, it definitely does help.
Yeah. And then I think the key thing, it's like, those grants have been instrumental to our success so far, but eventually do want to transition over to like a completely like market validated like business model where we don't have to rely on those grants for continued operation. So that's kind of the next stage where it's like, okay, now that we're getting closer to kind of refining like a number of features of our technology and some of our use cases, can we actually get people to reliably start, purchasing our services and access to our technology, so that way we can be less dependent upon those. So that's the hope.
Excellent. So, guys, this has been a fantastic conversation. There's a lot of interesting elements to what you're doing, and really looking forward to seeing where you take 8-Bit Cortex over the next few years. Any closing remarks from either of you?
Thank you very much for the opportunity. We really enjoyed sharing with you and all the awesome questions and insights and comments that we've received. Definitely informs our next steps going forward, and we'd love to see any of the participants here at one of our workshops, or helping us test and give feedback for our next steps. We're really making this for the community as a way for everyone to be able to improve their mental wellness.
Yeah, so I want to echo everything that Shannon just said. The community is a really big part of our vision. But I also want to acknowledge that you guys are really good hosts, and I haven't had a chance to nerd out about the science in this way before, so that was really fun and enjoyable.
Yeah, that's our USP.
Yeah,
if we have one, that's probably it.
Yeah. Wonderful job hosting.
Wonderful.
Yeah.
Okay. Well, and
I was going to say, Shannon always gets on me for, not using too much jargon when I'm doing the science. So this is the one I was like, I can actually say frontal parietal network and no one's going to get mad at me.
oh yeah, the good old FPN. Yeah, it's a good friend of ours. Well, okay. So thanks again, finally, to Brian for excellent questions and just being part of the team, and also to our audience who stuck with us, and those of us who are hearing us on YouTube or hearing us at some point afterwards. So thanks everyone for tuning in. This has been NeuroTechX Showcase Season 2, and we've had Ty McKinney and Shannon Snaden talking about 8-Bit Cortex. So thanks again, guys, and we'll see you all at our next discussion.
Thank you.
Thank you, everyone. Wonderful.
Good night.
See ya.